We think we have winter figured out, right? It gets cold, it snows, and then it's over. But sometimes winter bites back with a kind of fury that can bring our most modern cities to a grinding halt. And it often happens when we least expect it. We're talking about superstorms, these absolutely massive weather events that can bury whole regions under a blanket of snow and ice.
And get this isn't some old story from a history book. This is happening right now. Just imagine that for a second. You wake up at the end of April, you're expecting spring, right? But instead you look outside and your entire world has been thrown right back into the dead of winter. Well, that was the reality for millions of people in Moscow.
And we're not talking about a light dusting here. No, the city got slammed with 21 centimeters of wet, heavy snow. This absolutely shattered the daily snowfall record, a record that had stood for over 140 years. A record from 1880. Just gone in a single night. The fallout? Well, it was immediate and it was brutal. The sheer weight of all that snow just snapped power lines, plunging dozens of villages into total darkness. Flights were grounded at the airports, traffic was gridlocked, a complete standstill, and tragically, there were even fatal car wrecks reported. This is the real price of a modern superstorm, a major global city brought completely to its knees.
So, what on earth causes a storm of this magnitude? I mean, to really understand the chaos that unfolded in Moscow, we've got to look up, way up into the atmosphere, and take a look at the incredible machinery that powers these weather events.
So what kind of engine can possibly create a record-breaking blizzard in a place that's supposed to be heading into spring? Well, in Moscow's case, the culprit has a very specific and pretty unusual name. It's called an omega block. The best way to picture it is like a giant traffic jam in the sky. This huge high-pressure system just gets stuck. It stops the normal flow of air, and instead it acts like a massive conveyor belt that reaches up, grabs frigid air from the Arctic, and just funnels itself. And when that Arctic air crashes into warmer, moist air, boom, that's the collision that creates the perfect recipe for an explosive, totally unseasonable storm.
And what's so remarkable is that these powerful cyclones, whether they're powered by an omega block over in Russia or they're forming off the coast of North America, they often share this really distinct visual signature. They're not just some chaotic mess of clouds. They actually have a structure you can see.
And here it is. This is the classic comma-shaped cloud. I mean, look at that. This beautiful, swirling pattern that you can see from space is the hallmark of a really powerful storm. The head of the comma, that's where you'll find the heaviest snow and rain, while the tail is what sweeps that cold air around the center of the storm. It's an almost elegant-looking pattern for something that's so destructive.
Now, a comma cloud doesn't just show up out of nowhere. According to some deep research from NASA, you need a few key ingredients to all come together at the right time. First, you need the main event, that clash between frigid polar air and warmer, moist air. Then, you need a powerful jet stream to act like the storm's engine, giving it energy and spin. And finally, you often need some help from the local geography, something called cold air damming, where mountains can actually trap cold air near the surface, making that temperature clash even more intense for the storm to feed on.
But it's kind of like cooking. You can have the same ingredients, but you can combine them in different ways. And that same NASA research, which looked at decades worth of these storms, actually found two main recipes for how these monster storms tend to form, especially along the US East Coast.
Let's just call them Type A and Type B. A Type A storm is what you might call a coastal hugger. It develops down south and just barrels straight up the Atlantic coast, sucking up moisture the entire way. A Type B storm, on the other hand, is more of a one-two punch. You get an initial storm that kind of weakens as it hits the Appalachian Mountains, but then a powerful second storm rapidly develops off the coast, and that's the one that often catches people by surprise with just how intense it is. Either way, both paths lead to disaster.
And really, no matter which path the storm takes, the end result is almost always the same. We're not just talking about a snow day here. These are paralyzing events that can bring the most populated parts of a country to a dead stop.
Listen to this quote from that NASA study. It was written all the way back in 1985, but it could have been written yesterday about Moscow. The problem is timeless. These storms have, and I quote, crippling effects on major cities, completely overwhelming our infrastructure and causing huge economic problems.
The scale of this impact is just staggering. Just take one big snowstorm from that study, back in February of 1983. It directly affected more than 20 million people. 20 million! That is the entire population of a country like Australia. all just immobilized by a single weather event.
And this map just shows it so clearly. That 1983 storm wasn't some freak event. This shows the footprint of 18 separate major snowstorms over just 23 years. Each one of those shaded blobs is a massive region, often covering multiple states, that got buried under feet of snow. You can really see how this is a recurring, relentless threat.
But again, this isn't just a history lesson. As Moscow is digging out, another part of the world, northern Manitoba in Canada, is bracing for its own late spring blizzard. Meteorologists up there are warning about a massive system that could dump up to 50 centimeters of snow. That is more than double what just hit Moscow. Forecasters are saying that, yeah, spring storms happen, but the sheer scale and intensity of this one is really unusual for this time of year. And all of this brings us to the final, and maybe the most crucial piece of the puzzle. If we understand the ingredients, and we can see these storms coming, why do they still cause so much damage and disruption? Well, the answer is all about the huge challenge of forecasting them with perfect accuracy.
Okay, first, let's be really precise. The word blizzard has a very specific and very dangerous definition. It's not just about how much snow falls. It's that brutal combination of snow, powerful winds, and near-zero visibility that has to last for at least 3 hours straight. That dangerous combo is what makes it so life-threatening.
And here's the tricky part. Our forecasting models today are incredible, but they are not perfect. And as those same NASA researchers pointed out all those decades ago, even a tiny error in a forecast, just a slight wobble in the storm's track, can have a massive and devastating impact for everyone on the ground.
The single biggest challenge, the holy grail of winter forecasting, is predicting that rain/snow line. A storm's path shifting just 20 or 30 miles can be the difference between a major city getting a cold, miserable rain or getting hit with 50 centimeters of paralyzing blizzard-conditioned snow. It's a razor-thin margin, and that's where the battle of prediction is won or lost.
Which leaves us with a really critical question for the future, doesn't it? We know these storms are going to happen, we understand their ingredients, we've seen their history of destruction, and we also know the limits of our ability to predict their exact impact. So as our cities get bigger and bigger, the real challenge isn't just about getting better forecasts. It's about building better, more resilient systems to handle the winter storms that we know are coming.